Hello class, this is a video tutorial on the introduction to mathematical induction. So to understand the very basics of induction, let's consider this scenario here. I've got here a table of values where the first row is just the counting numbers 1, 2, 3, 4, 5, 6, 7, 8. The next row is I've made this a function of cubes. So 1 cube is 1, 2 cubed is 8, 3 cubed is 27, and so on. This third row, I've made it the sum of the first cubed up until the nth cubed. So for example, this is just 1 cubed. This row is 1 cubed plus 2 cubed equals 9. This 36 is 1 cubed plus 2 cubed plus 3 cubed gets us 36, and so on. But it also seems to be the case, if you look at a pattern here, this bottom row, well, it's not entirely obvious just yet, but take a look. This bottom row is 1 squared. This one here is 3 squared. This one here is 6 squared, and so on. Right, you can double check all of these in your calculator, but I assure you this is the pattern that's following. Now, if you look at it, if you look again even more closely, this fourth row is actually the sum of the first row. Well, at least the base is. By that I mean, if you take a look, well, that 1 squared, so I've copied down the exact same table. This is the these are the 4 rows. I've made a 5th row to really emphasize this. 1 is 1 squared. It's kind of obvious. But 3 squared, that's 1 plus 2 squared. And 6 squared is 1 plus 2 plus 3 squared. And it seems to be the case. That's kind of interesting. Now, if we substitute the sum of the arithmetic the formula for the arithmetic sum, n over 2, first plus last, we can make the following statement. Take a look. Well, if it's in the first row, we have 1 cubed is equal to 1 squared. Okay. 2 cubed, well, the sum of 1 cubed plus 2 cubed is the same as 1 plus 2 all squared. Just like that. 1 cubed plus 2 cubed is equal to 1 plus 2 all squared. And so on. 1 cubed plus 2 cubed plus 3 cubed is the same as 1 plus 2 plus 3 squared. And if we keep going to the nth term, 1 cubed plus 2 cubed plus 3 cubed plus on and on and on and on and on up until whatever nth cube that we want. It seems to be the case that it's the same as 1 plus 2 plus 3 plus 4 plus all the way to the nth all squared. Well, because this is an arithmetic series, we just substitute that in, which will conclude with this equation here. If we expand this, this becomes n squared divided by 4, because we're squaring that as well. 1 plus n, which is first plus last, all squared. So we can conclude with this. But is this statement actually true? From just observing, we seem to have come to the conclusion that 1 cubed plus 2 cubed is the same as 1 plus 2 squared. If we continue this all the way into the nth term, 1 cubed plus 2 cubed plus 3 cubed plus all the way to the nth term, summing all the cubes, is that the same as the sum of the numbers and then squaring them, just like this? Is that true? Is it actually true, or is it only the case for up until 8? That's the question for mathematical induction. So what we've ended on, this one here, this is called a conjecture. Right? It's a mathematical statement. We have evidence for it, as shown here, but isn't mathematically true for any situation. Okay, so it still requires proof. Now, this is just one conjecture. There are heaps, there are infinite many conjectures that we can make. Right? There needs to be extensive ways to prove conjectures to actually be true. This is where the method of proof by mathematical induction is applied. What we will learn is more on the method and less on the discovering of these conjectures. So what we'll be looking at in this unit is we'll be given these sorts of statements, and we need to work to prove whether they're actually true. So in this example that we've done, you can say that the sum of the cubes of natural numbers, so 1 cube plus 2 cube plus 3 cube plus up to the nth cube, is that the same as the sum of natural numbers, so 1 plus 2 plus 3 plus 4 plus 5 and so on, all squared? Is that statement true? What we will learn is called mathematical induction. So I hope to see you in the next video where we actually start learning the method for it. I'll see you then.